so much for your time today. Really, really fun to be with you all. My name is Ben, and I'm one of the co-founders of Circular 11. So we have developed a machine learning-driven manufacturing process that takes in unrecyclable plastic waste and turns it into a carbon-negative building material. We deploy that material at the moment as manufacturers in a whole range of outdoor applications where it functions as an alternative to timber, but one that lasts a lot longer. And we're, by acting as a manufacturer, generating the data we need to train our system to the point where we hope we can deploy it as an independent manufacturing technology in other sectors. But we'll get to that. And hopefully my goal for the next 10 minutes, and I'll try and keep it short, is to make that make sense a little bit more. We will ride out the formatting, just bear with all of that stuff. But I really want to zero in on a specific part of the plastic recycling value chain that we're trying to solve. We all know that plastic is a problem. We all know that plastic demand is increasing at a huge pace. That's not really the point that I want to communicate. Most of the plastic that gets to a recycling center ends up being incinerated because it is too mixed together to be useful to manufacturers. Now, you can treat that like a recycling problem, or you can treat that like a manufacturing problem. And we're one of the only teams that I've seen trying to tackle the plastic recycling challenge at the manufacturing point. A lot of this stuff was touched on by Scarab Tech, so hopefully there'll be a little bit of fluency in the room already, but forgive me if I'm going to overlap with their presentation slightly. Plastics are useful because you can tailor them so specifically to their application. There are thousands of different additives you can put into plastics to make them just right for the application that it was intended for in a virgin material. But that's what makes recycling so challenging. So you have all of these different plastic types, and they're all mixed together when they go to a recycling center. Now, there is separation technology, and that separation technology separates them out by their different densities, for example. It separates them out by their different electrostatic potential, but they're just not very effective. At best, you might get a 60% yield, and so you always have humongous tranches of mixed plastics that are the output of recycling centers, and they're one of the biggest reasons why recycling is such a difficult industry, and you see recycling plants closing rather than gaining ground. It's because it costs money to incinerate them. That incineration is a hugely carbon-intensive process, so we're looking at about 160 million tons of carbon emissions at the moment, but the UK is just rolling out more incinerators and more incinerators every single year. This problem is going to grow and grow. It's already 0.5% of global carbon output, but I see this as being a problem that keeps on growing. So really we want to say, why can't manufacturers use mixed plastics? We're trying to exploit a really crucial fact with plastics, which is that they often have synergistic properties. So like polypropylene, really strong, really good impact resistance, but terrible in UV. Something else, like HDPE might be a good all-rounder. Polystyrene might give it a really good surface finish. So if you look at a lot of manufacturing sectors, they deliberately combine plastics together anyway. The problem is you can't just take a waste stream, put it through a processing line and it behave great. You've got to bond it in very specific ways. And if you take stuff from a recycling plant that's mixed, you're never going to have the control that you need to make an output that's consistent. So manufacturers can't use mixed plastics because they can't control the quality of the output. I'm going to get to what we do in just a second, but I want to contrast this with a very different kind of problem in a different sector, which is construction. This is an oversupply problem. So this is supply, and demand for recycled plastics is nowhere near this curve. But in contrast, if we look at construction, we see a very similar but inverse curve. So this is the demand curve for timber in the next 30 years. If you want to decarbonize buildings, cross-laminated timber, other kinds of timber, really, really important. But timber takes 20, 30 years to grow. It just is not going to keep up with the demand that's there. There's increasing forest fires, there's increasing pressure. And really crucially for our customers, you're seeing the banning of timber preservatives globally, but in 2023, for example, it was finally phased out of the EU. You can't use creosote, and you can't use all of these other timber preservatives because they're toxic. So the lifespan of this critical material in the construction sector has just collapsed. It was 30 years 10 years ago, But people that have installed their timber fencing, for example, 5 years ago, are already replacing them. And if you're like a road infrastructure provider and you have 100,000 kilometers of fencing on your network, this is a very, very, very costly issue. So we try and exploit the fact that we've got an over demand of one material and we've got an oversupply of the other. What we really need to do is to transform plastic mixed streams into an effective feedstock for the construction sector. And that is what we try and do at Circular 11. So we are manufacturers developing a building product, but we are also manufacturing technologists who are developing a process to regulate the quality of mixed plastics and create a standardized output. I'm not going to go into the technical details too much, but if I just try and, a decently formatted slide for once, I'll try and simplify this slightly. What we do is we take mixed plastic inputs, and one of the critical pieces of the technological puzzle is real-time characterization data. There are already techniques to do this. It's called spectroscopy, and it's really standard, but it does not give you the kind of information you need to do anything on the manufacturing line, because it doesn't give you quantities of plastics in the input stream. If you want that, you need to do lots of much more time-consuming characterization methods. They're not appropriate for manufacturing. They take way too long, and so at the moment, that's one big issue. So we are developing novel ways to characterize plastic streams in real time to generate the data inputs that we need to train the algorithms. And what they do after training is optimize every single part of the manufacturing line and the compounding, the recipe stage, where you add in a stabilizer, or you add in something that bonds plastics together, or you adjust one of the plastic properties that you're looking to tailor in many ways. The algorithm will work out the optimal formulation to do that, and it will work out how we need to adjust the manufacturing process in real time. And that is the crucial heart of what we're doing to create a standard output. Now, we have started as manufacturers where that's easiest, and that's plastic lumber, a timber alternative. And what we began doing when we were starting out this company, we started by getting a business loan and going into an old Hovis van, setting up a mini extrusion line and seeing how we could regulate the quality of all of this plastic mess that we were getting on our hands. We started by making products because a lot of the margin of the product is in the assembly phase. So we made all sorts of kinds of structures for all sorts of councils, governments, theme parks, Wembley Stadium. We've done all sorts of pretty random applications, but all in the outdoor material space. But we really wanted to make this, our competitor is a timber factory. We wanted to make this a scalable building material proposition. We didn't want to stay in the product stage. So we've shifted towards high volume component supply, more like what a timber factory is. We pump out a lot of planks and we sell them to, we sell them as fencing, we sell them as subcomponents to customers whose maybe average contract size is 2 million, 3 million, 5 million pounds rather than a few thousand pounds like you get in the product scale. I'm going to whiz through this kind of side of things because this is more on the commercial side of things, but we use waste that we get paid for taking in, and we get paid up to £600 a tonne for our input stream. Normal plastic manufacturing, if you're going to buy HDP on the recycled market, it costs about £800 a tonne. Now we have some processing costs, of course, but this really gives us a radically different cost of goods and a radically different gross margin profile to normal manufacturers. And yes, we could try and keep the premium and just be a boutique but very high margin material supplier, but we actually want to make an impact in the plastic recycling space. And to do that, we need to sell at volume. If we sell at volume, we need to address the price, because at the moment plastic lumber is already a thing, but it's made from expensive plastics and it's a lot more expensive than timber. So we can get the price a lot lower to timber. This preserves a 35–40% operating margin, which we'll get onto, but we can get much closer to timber. And most importantly, it lasts 6, 7, 8 times as long. We divert a very quantified amount of plastic from incineration, and that allows us to have environmental product declarations that say it's carbon negative, you can use it. And that's how we've got a large number of our contracts with bigger customers, because they don't know what they're going to do to hit their carbon footprint targets. So we've got stuff with national highways, we've been rolling it out to councils, and at the moment something has happened in the last 3 to 5 months where it feels like we've hit product market fit with the material regulation, the certification and the price. Because all of a sudden, we're in this pokey facility that can produce about £400,000 of product per year, and it is nowhere near enough for any single one of our customers, let alone all of them. So we've been working a lot with various ranges of partners to map out a supply pathway, and we're raising money at the moment to try and expand tenfold our capacity so that at the end of the year we can start to meet a lot of this. In general, there are two sides to this business. There's us as manufacturers and there's us as a manufacturing technology. We want to be bringing this to emerging markets because I didn't introduce at the start, but this whole company started because I was working on waste management projects in Nepal. I was coming from the international development sector, and I was going to bed each night with the smell of burning plastic in our nostrils, starting to ask the question, why am I smelling plastic every single night, which Gareth Tech was also talking about. That led to us looking at waste valorization. And for me, emerging markets is where this technology has to work. To do that, we don't want to be the owner-operators necessarily. We're not going to be well placed for that. So developing ways that we can bring this technology as a lumber factory model and map it out overseas, that's the crucial challenge after we validated this first facility. My co-founder hates me using this photo because it's messy, and I just wanted to show the facility and what we're doing at the moment. We've raised over £1 million to get to where we are today. We've done world-first recycling pathways for plastic categories that can't get recycled in the UK, different types of artificial grass, different types of plastic film, a large range of thermoplastics that have no recycling pathway. And we've turned them into commercialized products that have good margin. Really crucially for us, we're trying to scale on a proposition that this is also an incredibly commercial opportunity if you can turn waste into a very valuable building material. So we're looking at operating margins in a double line triple shift of about 32–34%. And we don't really want to go over 5–6,000 tons per facility because it becomes a nightmare. So this for us is what we're trying to build to over the next 2 years once we're in our new facility. It's a 10 million ARR facility, and it has about a quarter of that in EBITDA bottom line. For us, we're a team of machine learning specialists, polymer engineers. We come from trades. We've got production teams. We're a team of 10 right now, and we need to really build that out if we're to start scaling this as a kind of production model. So what we're doing is we're raising £2.5 million. We are opening that round on March the 1st, and I would really, really love to talk to anyone interested. If you are raising, if you have a fund and you have dry powder, I would love to talk to you. If you know investors that are interested in materials, in decarbonization, in emerging markets, or in any category that might be relevant, I would deeply value an intro. And also, if you're potentially a partner, if you know waste supplies, if you have complementary technologies, then we really need to build this into an ecosystem, because that's what waste needs in order to become fully valorized. And I won't talk about anything more. I won't talk about all of the software side of things and how to create data pipelines. I've done a terrible job at talking about market sizes, but I'll leave it there for now. Thank you very much for your time.